As we look at this problem, we're going to be looking at how to graph linear and exponential functions and their key features. This is an example of a linear function. As you look here, this isn't set up in the same notation as this. So this is an example of slope-intercept form. So before we begin to graph, we want to transfer to this equation into that form. So we're going to go 15 minus y equals negative 4 times x minus 3. What we're going to do here is we're going to distribute and get negative 4x plus 12, and that's going to be set equal to 15 minus y. Now we're going to subtract that 15 to get that y by itself. However, you notice now that it's all negative. So what we know now is that we can divide off a negative 1 and get our final equation as y equals 4x plus 3. So now that it's in this form, we can move over to the graph. As we begin graphing, I always like to start by creating a chart. So you have an x and your y values. So what you're trying to find is your y values. So you can look at the sides here and choose 3 to 4 points. So I'm going to start with negative 1, 0, 1, and 2. So we're going to try and identify those 4 points on the graph. So as we see here, we'll solve for negative 1 first. Do y equals 4 times negative 1 plus 3. And that'll get you y equals negative 4 plus 3, and that'll set you equal to negative 1. So negative 1 and negative 1. Go to the next one. Y equals 4 to the 0 plus 3, and that'll just be 3. Continue on. There we go. So now we have our chart. Next, we want to start by identifying the points and matching them on the graph. So we have to know that that's negative 1 and negative 1 for the first point. Do a big mark. You know that's going to be x right here and 3. So this is our y-intercept. Now here, we know that 1 and 7. Now granted, this graph only goes up to 10, but we know that 2 and 11 would be right around here. And there is an example of a linear graph.